Good evening, everyone. Am I audible? Hello?
Good evening, madam. Yes, madam.
Yeah.
You are on.
Okay. So, welcome to the class. This is Environmental Engineering course for the subject Environmental Chemistry. So, I am TA for this course. I will help you with the doubts as well as we will solve some questions which can be helpful to solve the assignments. So I hope as discussed in the class you are well aware that this course is mostly for the postgraduate students and the environmental engineering professionals. So there might be few things and I have noticed that few juniors have also joined this course, like some of them are from BTech as well. So if there is any problem in the course, understanding the concept or anything, then I'll be there, I'll help you. So I'll introduce myself now. I am Mansi Tripathi. So I am currently pursuing PhD at IIT Madras under Professor Liji Philip in Environmental Engineering Division. So I have gone through this course like thrice in my life during my BTech, MTech as well as PhD level. So I hope I'll be able to help in this course for you people. So for now I'll share my screen, then we can see few questions, and in case of any doubts you can ask me in between or at the end of the questions. Okay, so I'll share my screen now. I hope this is visible. So as we discussed, this is the environmental engineering course. This is first week of problem solving session. So parallelly two such problem solving sessions are running. Okay, so one is from another by another girl, I don't remember her institute, and one is offered from IIT Madras. So both of us are pre-MRF students. So we are getting this opportunity to teach the same course or as a doubt solving session to you people. Yes. Please take full help from this course. Okay, so we'll see the first question now. So these questions are kind of similar to your assignments but not exactly similar to the assignments. Numerics will be changed, and in some question concepts are also changed. So if you are looking at the assignment from this semester and the courses and the assignment questions that I am showing, if you will combine both of them, you will get full knowledge of the course. So first week was mostly very basic. We were talking about what is equilibrium, what is kinetics. Like as we discussed in class, kinetics is how fast the reaction is happening, and equilibrium is how far the reaction is gone. So this is the two basic things regarding kinetics as well as equilibrium. Then we talked about Gibbs free energy. So as we know that if Gibbs free energy is negative, we can say okay, the reaction is feasible, and if Gibbs free energy is positive, reaction is not feasible. So all these concepts were very well discussed in class, but still in case of any doubt you can ask me in between. I'll also post my website in the chat box so that if between two sessions you are getting any doubt, you can ask me there as well. Let's have a look at the first question. The first question is very simple. We have to convert the given concentration into equivalent units. Equivalent units here will be milli-equivalents, because as we are seeing these values are given in milligrams per liter, so it's better to convert them to milli-equivalents rather than equivalents, because equivalents is mostly in grams. So these are why do we need this milli-equivalent thing? So first of all, the very important point is if we have two contents in a reaction, one is A and one is B. So only 1 gram equivalent of A will react with 1 gram equivalent of B. So like for example, if we are doing, I hope you know what is adsorption experiment. If there is a site, there are so many adsorption sites, okay, and you are putting two contaminants. One is of say 1000 molar mass, other is of say 100 molar mass. So if we want to compare which is getting absorbed more and which is not getting absorbed properly, okay, so we need to understand these things, that we cannot just put a 100 ml 100 milligrams per liter and B 100 milligrams per liter. That won't make any sense. So what we should do is to, if we want to compare which is getting absorbed more and which is getting less absorbed, we should compare them with in a common ground. So that common ground is equivalent weight. Okay, so that is the only common ground by which we can compare two compounds of very far range, which falls in very big range of molar mass. So that is very important. So if there are two compounds having molar mass like 200 or 210, then in practical application there won't make any difference. So even if they are in concentration units like milligrams per liter or grams per liter, then there is no problem. But if the molar mass is very diverse, here comes equivalent units. That is why we should learn how to convert the concentration into milliequivalent units. So we'll see this question. So there are three compounds: calcium sulfate, magnesium sulfate, and calcium carbonate. We have atomic weights of all the compounds. So please try to solve this question. You have learned, like, this is very basic, so sir has not taught this in the class, but it is expected you to learn all these things. You should be previously well aware of all these things. So this is just a question, please try to solve, otherwise we'll see the solution also. So I'll give you a minute to solve this question, then we'll see the solutions. Okay, we'll see the solution now. So to convert anything into equivalent weight, so what should we do? Equivalent units is equal to number of equivalents per liter. See, when we say CaSO4, how it deassociates? Ca2 plus SO4 2 minus. So this is the valency in which it dissociates. So this we will use to find out the equivalent weight. So this 2 here, here and here is coming from this valency. If this is aluminum chloride, then the valency can go to 3 plus. So in place of 2, 3 will come. So what is CaSO4? It is mass, equivalent weight, mass upon molar mass, divided by valency. So this is equivalent to it. Okay, so here why valency is coming? So as we have seen, I have drawn this previous diagram. The particles having most of the particles having valency 2 plus are bigger than the particles having valency just plus. But the size of these adsorption sites is same. So sometimes some of the particle will come and sit here, or in same site, like just say if this particle adsorption site is equivalent for this thing 2 plus, then it is also possible that in some sites 2 plus plus molecules are 2 monovalent are coming and sitting. So this is also possible. So which one will get absorbed more is this one. So this thing is applicable only when the molar mass are equivalent, 200, 210. But if there is huge gap, then this thing won't be enough to predict which one is going to and sit on the adsorption site. So that depends upon various factors. We will learn this thing in due course. So this is just for example, that if there is one place, bigger particle will take if 1, then smaller particle can go 2. So which one will be interacting more or reacting more is smaller one. So that is why we need to learn the equivalent way, so that we can compare two particles having different valency. So as this is for CaSO4, it came to milliequivalents. This is the mass that was given, 36 milligrams per liter. This is the molar mass and this is the valency. I hope there is no doubt in this question. So we'll move forward. In case of doubt, you can ask me in between. There is no problem in interacting. So we'll move towards next question. This question is also similar. Now here we want to convert the same values in molar units. Here we are not talking about the equivalents. Here we are talking about just to convert them into molar units. So here in this question, the valency is not going to play any role. There are certain phenomena where valency is important, but there are certain phenomena where it is not much important. So here we just convert them into molar units. Please try to solve this question. We'll see the solution in a minute. we'll see the solution now. So as discussed, there is no role of the valency to be played here. So this is just mass upon molar mass, which is number of moles. So it is well recommended that you come up with like you should read mole concept very properly before coming to class, because most of the things will be related to mole concept only, like difference between molarity, molality, equivalent mass, normality, where molarity should be used, where normality should be used, all these things. So this is a prerequisite. Please go through some basic books so that you can learn all these things. One basic book can be Stoever and McCarty, Environmental Engineering, Environmental Chemistry for Environmental Engineers. Stoever and McCarty. This. So book's name is Environmental Chemistry for Environmental Engineers, something like that. So that will help with all the basic experiments as well as all the basic concepts of chemistry. So we'll see next question now. Select the correct option. This is a theoretical question. All steady state processes are at equilibrium. All equilibrium processes are at steady state, and equilibrium is defined only for closed system and steady state is defined only for closed system. So this part was very well discussed by sir. He was giving example of a batch system as well as continuous system. Batch system means there is no incoming and outgoing flow. Like you are taking something, let's say you are taking NaCl in water, and after some time you are measuring the concentration of chloride or sodium. So there are various equipment which are available which can easily measure these anions or cations. Like you can simply measure how much sodium is there, how much chloride is there, or if there is anything else, that also can be measured. And he talked about a CSTR system in which there was inflow as well as outflow. So which of these are correct option? So someone has answered it's option 3. Yes, it is very true. Steady state can be reached even in a river. Like in natural river it will never reach, but in an ideal condition it can be considered that the rivers, some rivers or the man-made water bodies are in steady state. So river or water bodies or open channel flow, these are not closed system, right? So this option is not there. What is steady state? Steady state simply means the parameter is not changing with time, and equilibrium is only applicable for the closed system. He gave, while giving this example, he told we can check if we are cutting out the inflow and outflow. If still after some time there is no change in any parameter like concentration, pH or anything, then only it can be considered an equilibrium condition. And see, even here what is happening, we are making the system close, then only we are able to say if the system is in equilibrium. So for any equilibrium it has to be closed system, nothing else. If there are any places we are saying it is in equilibrium, we are first converting the system to be closed, then only we are measuring the equilibrium. Here concept of control volume will come in future classes, then we will see. So when we say control volume, it also means a closed system. We are taking a volume that is fully under our control. Like it's a layman language, but it is a kind of closed system that we are considering for solving that particular problem, or for looking at a particular set of parameters for that particular area. So option C was correct. Let's go to the next question. So this is also a numerical type of question. Here benzene is dissolved in water to form a solution of 1 liter with the concentration of 55.6 moles per liter. The initial concentration of benzene in pure organic liquid form is 800 milligrams per liter. Calculate mole fraction of benzene in the given solution. So benzene is dissolved. Firstly, initially there was some organic solvent, let's say methanol or ethanol or anything. Here first benzene was dissolved. Here the concentration was 800 milligrams per liter. Now this is dissolved in water of 1 liter. So this is a water matrix. Volume is 1 liter. And here the concentration of benzene is 55.6 moles per liter. So we want to calculate the mole fraction of benzene in the given solution. So now we want to calculate the mole fraction in H2O, in water. Given solution here is water. So what is mole fraction? Mole fraction is, if there are 2-3 substances, what is the fraction of the target pollutant of target substance in the whole matrix. So here 2 things are here, right? Now we have H2O, here we have H2O also, and we have benzene also. I am writing benzene as C6H6. This is benzene. So here we have both the things. So we want mole fraction. Mole fraction is C6H6 H2O plus C6H6. So this is also one of the basic concepts that we should learn when we are adding 2 different liquids or of same nature as well as different nature. So please try to solve this question and we'll see the solution in a minute. Okay, we'll see the solution now. So the mole fraction of benzene is equal to moles of benzene divided by total moles in the solution. So we have this in milligrams per liter, so we wanted to calculate it in moles of, first how many moles are there. So as I have told, the formula is C6H6. So molar mass of carbon is 12. So 12 multiplied by 6. So this is how it is coming, and molar mass of hydrogen is 1, or atomic mass. So multiplied by 6. This is in milligrams per liter, and moles is calculated mostly in gram per moles. So this is 1000 is the conversion factor. So this is what we got, moles. And this is the total moles in the solution, 55.6. So this is how we got the mole fraction. This is y4, and these 4s are in superscript. Okay, this is a typing mistake. So we'll move towards next question. Calculate Gibbs free energy for the reaction below. Here we can very well see this R is talking about the reaction and this is talking about the standard condition. Okay, this degree sign is talking about the standard condition. So when we say standard condition, temperature is 25 degrees Celsius. So while solving the questions, we will revise the concepts a bit. Okay, so that will be helpful. Pressure is 1 atm and activity is 1. So this is the standard condition, and here data is also in the form of standard condition. So it's very quick question. So please try to find out the Gibbs free energy of the reaction, and these are the options. And Gibbs free energy, as we can see from here, Gibbs free energy of the elements is 0. Gibbs free energy of the formation of the is 0, and we have to find out the change in Gibbs free energy of reaction. And please do tell me if the reaction is feasible or not. Please try to solve this question, then we'll see the solution in a minute. We'll see the solution now. So Gibbs free energy of reaction is Gibbs free energy of formation. I'll write Gibbs free energy of formation of product minus Gibbs free energy of formation of reactant. This is I am writing in short. So what is the product? It is Fe2O3 in solid form. It is a kind of precipitation reaction. Okay, so no, it's a combustion reaction because oxygen is acting on FeO. So we'll see how it comes, and we'll check if the reaction is feasible. So what is the Gibbs free energy of product? Is minus 742.7. So minus 742.7 kilojoule per mole. Now minus Gibbs free energy of reactant, which is FeO and O2. So FeO, what it is? Minus 251.1, and for oxygen it's an element, so it's 0. Now we are seeing there are 2 moles of FeO, so this is multiplied by 2, and this is what we got. So it is in minus. When the change in Gibbs free energy is in minus, so this reaction is feasible in the form it is written, means it is real. If we are reading it as forward reaction, so this reaction is feasible in forward direction. Okay, backward is not feasible. Moving towards next question. Comment on the feasibility of the given reaction. So it is kind of similar to the previous question, but here we are talking about equilibrium constant and reaction quotient, if you remember. So here we have to find out if the reaction is feasible. Please calculate the Q value and check if it is feasible. I hope you have calculated. This is pretty much simple. We'll see. So we are calculating the reaction quotient Q, which is hydrodium ion. These are the products. These are the reactants. So products divided by reactant, and if in case there is any coefficient, we should also include that in form of power. So we are doing all these things and we got 10 raised to power minus 8. And what is the equilibrium constant? It is 10 raised to power minus 7.53. Since Q what we are getting is less than K, the reaction is feasible because it will move. Still it is yet to reach equilibrium. Okay, equilibrium is still, there is still some time, it is not yet at equilibrium. So it will reach equilibrium in some time, which will come in forward direction. So that's why the reaction is feasible. Select the correct option. Delta G is state variable. Delta H is inversely proportional to delta G. Delta S, which determines entropy, is directly proportional to delta G. And if the number of moles of product is more than the reactant, degree of disorder decreases. We have to find the correct statement. So delta G is delta H minus T delta S. So this is statement. Delta S is inversely proportional to delta G. It's not like true. Delta S is directly proportional to delta G. So there is as such no proportionality relations here, because there are three different terms which needed to be considered here. And this part is the number of moles of product is more, degree of disorder decreases. So no, it's not, it increases. So the answer is option A. Delta G is state variable because it does not depend upon the path. What is difference between state variable and path variable? State variables just depend upon the state in which they are in, and path variable means how they are reaching to that state. So for example, if we are talking about physics, we can say the difference between distance and displacement. So distance, if you want to reach from this point to this point, either you can come from here or you can directly go there. So displacement is just this distance. So this is displacement. So this is kind of state variable. And distance is path variable because it will depend upon different path. Either you are going by A plus B or directly following C. So the value of distance depends upon what path you are taking. So that is path variable. So this is the difference between state variable and path variable. So delta G is just a state variable. It does not matter how you are reaching that state, by combustion or by precipitation or by dissolution, doesn't matter. You should reach that state. That's all it wants. So that's why it is state variable. Moving towards next question. Analysis of the water gave concentration of sodium calcium chloride bicarbonate as these milligrams per liter. So we want to calculate the ionic strength of the water sample. So there are various equipment which can very precisely give what ions, and they can quantify them also. Is there in water body or any water sample, and now we want to calculate the ionic strength of the water sample. We have the molar weight and we have the formula also. So please calculate the ionic strength of the water sample. see the solution now. So it's better to do such questions in the form of table. So ionic strength is Mi Zi square. So Z is your the values, means valency, and M is, you can see that this is means molarity of the component. So mass divided by molar mass. So we need to calculate the molar mass as well. And these 1000 are the factors. Here also 1000 will be there. And here also. These are conversion factors. So mass, sodium was given 9 milligrams per liter, and the molar mass is 23, means atomic mass, because it is an atom, so atomic mass we can say is 23 divided by 1000, because 23 is in gram per moles and this is in milligrams per liter. So we will convert both of them into grams. So same for calcium, chloride and bicarbonate. So here, because the valency is 1, so here 1 is coming, but for calcium valency is 2, so that's why 2 is coming. Now these are Z square, then Mi Z square. We will take out the summation. So this is our summation, and ionic strength is 0.5 multiplied by this value. So we are multiplying 0.5, and this is how we got 1.7 into 10 raised to power minus 3. So in examination also such kind of question will be coming from this first week. So we'll move towards next question. Select the incorrect option. Henry's law is applicable to dilute liquid gas interaction. Raoult's law to non-dilute liquid solid liquid interaction. For hydrophilic compound, KOW value is lower. KOW is octanol water coefficient. So octanol is non-polar liquid, and water is, as we know, polar solvent. So for hydrophobic compound, KO value is higher. So please let me know the answer of this question. We have to select the incorrect option. This is the second last question. After that we'll see one more question of the numerical nature, then we'll close the session. We'll see the solution now. Here we have to consider incorrect option. Okay, so please be mindful of that. Last time many of the student has this mistake in examination. So Raoult's law applies to non-dilute liquid gas interaction. So the correct option will be, what kind of interaction? Non-dilute is correct, but what kind of interaction? You can write the answer in the comment section. We can discuss this after 10th question. Meanwhile, you can write the answer in the comment section. What kind of interaction we are referring to? Oh, means here answer is already written. Here the wrong was solid liquid, but yeah, it's non-dilute liquid gas interaction. Sorry, I have already written the answer. Okay. Now we will look into last question. The small amount of energy available in methanogenic process forces the microorganisms involved in very efficient cooperation. So here we are talking about anaerobic digestion. So in anaerobic digestion or in any anaerobic process, there are many stages. First, the bigger organic molecule is converted to smaller molecules, smaller acetic acid. Okay, then further methanolytic process takes place. After that, that compound is converted to methane. So these are example of such type of process. It's written in other language. So we'll see what this question wants us to find out. In many cases, neither partner can operate without the other. That is, together they may exhibit a metabolic activity. Means such cooperation is called synotrophic relationship or symbiotic relationship also. This is a chemical kind of reaction. Apart from this, the most common symbiotic relationship is among algae and bacteria. We'll see that later. So a typical example is Methanobacillus melansky culture, which is a co-culture of two partner organisms, strain S and strain MOH. They cannot work alone, they have to work together for this synotrophic culture. The two strains cooperate in the conversion of ethanol to acetate and methane by interspecies hydrogen transfer as follows. So please first of all note down these two reactions so that we can go to next page and see what this question wants us to answer. So two strains are there. These are bacterial strain. One is S and one is MOH. One is converting ethanol to acetate and other is producing methane from hydrogen and carbon dioxide. In first reaction, while ethanol is converted to acetate, hydrogen is produced. Okay, but if this hydrogen starts accumulating, see, first of all we should know our final target. Our final target is methane, because this is a biogas that this can be used for various energy extensive practices. Okay, so in the first reaction, hydrogen gas is produced. If somehow this hydrogen gas is consumed, as in second process, the concentration of hydrogen will reduce. So this reaction will move in forward direction. So for conversion of ethanol to acetate, we need more, we want this hydrogen to be used as methane. Okay, then only this reaction is feasible. If we keep on accumulating hydrogen, this reaction will go in backward direction. So that is why for this reaction to be completed, for the reaction to be completed by strain S, reaction of MOH is important so that hydrogen can be utilized. I hope you are getting the point. I'll explain again. If we want ethanol to be converted to acetate, okay, we want this reaction to go in forward direction. For this reaction to go in forward direction, we decided, okay, let's consume hydrogen. While consuming hydrogen, the concentration of hydrogen will decrease. So if the concentration of hydrogen will decrease, the equilibrium will be disturbed. So to maintain the equilibrium, more and more ethanol will be converted to acetate. So this is what we want. So here, to reduce the amount of hydrogen, strain MOH is coming into picture, which is converting the hydrogen to methane. Okay, the critical point in this synotrophic cooperation is that the reaction that strain F means the first reaction is catalyzing is only exerogenic reaction, means negative XR, means first reaction is feasible. If the H2 partial pressure or the H2 concentration is low enough, this reaction is feasible only when H2 concentration decreases, then only it will go in forward direction, as I have already explained. So this is feasible only when Q is less than, okay, when the equilibrium is disturbed. So that is only when it converts to it gets negative negative G value. So hence MOH must remove hydrogen efficiently from the solution.